Hello, this is Jimmy is wrong with problem 10 solution. This was especially confusing for me because it's talking about gravitational acceleration in a more vague way because it doesn't explicitly say that it's on Earth, right? So let's just read. Consider the following three solid objects, each of mass m. Okay, so that's clear. So you have a half ball, which is just a hemisphere, a cylinder of radius a and height a, and a cylinder of radius a and height 2a. So for each object, consider the gravitational acceleration at the center of its flat circular face. You can see I've drew the three shapes here, the three solids, and we are referring to this point. Okay, so let g bar, g and g2a denote these accelerations. Which of the following is correct? And we are asked to compare their magnitudes. So for each of these, it's not talking about Earth's pull on them. It's talking about the field that these generate themselves. So for example, in this half ball or hemisphere, there's a bunch of points spread around, and they each pull at the center of the face, and that's the gravity we want. So remember Newton's force, gravity force, universal, force of universal gravitation. So it was Fg is G constant m1 m2 over r. In this case, this mass is the mass of the whole solid, and this mass is just a mass of an arbitrary point of the solid. And r is the it's r squared. Sorry, so r squared. So r is the distance from that arbitrary point to the center. Right. And so a is then dividing this by this mass. So gm over r squared. Yeah, and for clarity purposes, this should be sum. This should also be a sum. Because there's a bunch of variable points that we have to integrate in, right? You can realize here that A, due to the field, is proportional to 1 over r squared. So as r decreases, meaning the solid is more closely packed, as the distribution of mass, it's kind of similar to the concept of moment of inertia, right? Is closer to the center, there is more acceleration as a result. So hence it follows that G ball, because here the mass is closest. Sorry. Here the mass is closest to here. Here there's these corners, and here it's common sense, right? This whole portion is further away from the center. So we have G ball is greater than GA is greater than G2A. I will highlight this, and that corresponds to C. And it's satisfying when you can automatically create a box. Thank you for watching, and have a good day.